In this video, I would like to discuss Newton's first law. Newton's first law states that an object at rest remains at rest, or an object at constant velocity will remain moving at constant velocity unless there is some unbalanced forces acting on it or a net force is acting upon it. When an object's forces are balanced, we say that the object is in equilibrium. That is to say that the net force acting on an object is zero. There are no net forces acting on it. To express this equilibrium rule, we write mathematically the sum of the forces is equal to zero. So this symbol over here, the summation sign, really stands for the sum of, and F stands for forces. So it's the sum of all the forces, and they simply add up to 0. Alternatively, some people will simply write the net force is equal to 0 because the net force is representative of the sum of all the forces. Often people have misconceptions regarding the relationship between force and motion. For example, it was once believed that a force was required to keep an object moving. The great philosopher Aristotle believed that it was a natural state of objects to stay at rest, and that there was a force required to keep an object in motion. However, some 2,000 years later after Aristotle, Galileo Galilei disagreed. He argued that it was natural for an object to be in motion with constant velocity, as it was to be at rest. Through observations of balls rolling along surfaces that were tilted at angles, we see that when a ball goes up an incline, the speed decreases, and when it goes down an incline, the speed increases. But what about along a horizontal surface? If there's no slope, does the speed change? Well, he reasoned that a ball rolling along a horizontal surface would continue to move forever and ever, as if you assumed if there was no friction. He reasoned that a ball rolling down an incline would roll up on the opposite incline exactly to the same height. And that would be present in both this scenario A or B. But what about C? And if there was no friction? Well, then this ball would really never ever stop unless it hit something. So imagine a world with no friction. An object moving along the horizontal surface would just keep moving along forever and ever at constant velocity. So no force is needed to keep an object in motion. This leads us to a key idea or key term called inertia, which is shown here in bold. Inertia refers to an object's resistance or sluggishness to change its state of motion. If an object's in constant velocity, it's just going to continue moving at constant velocity. It's going to resist any changes in acceleration. So inertia, by the way, is not an interaction between objects. That means it's not a force. It's a property of an object. So how does one measure one's inertia? Well, we measure an object's inertia by measuring its mass. Mass is a measure of an object's inertia. The more mass an object has, the more inertia it has, and the more force will be required to kind of change that state of motion. So what are some conceptual examples of Newton's first law? Here's an example of a test car crash. You can see that the dummy's head is moving forward and crashing into the glass. What force do you think is causing the dummy's head to move forward? Is there force acting on it? Well, it isn't a force that does this. By Newton's first law, the dummy wants to continue at a constant velocity, maintaining his velocity. His head stops simply because he hits the windshield, or better yet, an airbag, as shown in the video here. Here's another maybe not so funny example, but this is an object at rest that wants to remain at rest. Here's another example of a balloon being pricked or popped open, and the water is still staying in that same state of motion because of Newton's first law. I'm not sure if this one's true, but this is the old famous tablecloth trick performed by yours truly, the Pope. An object at rest wants to remain at rest. Sometimes they just simply call this the oldest trick in the world. Was part of a BMW commercial years ago, and there's the tablecloth trick, and now he's going to perform it with a motorcycle. Do you think this is true? What's he going to attach that to? Once again, this is Newton's first law. And my last little video clip is, how do you get the ketchup out of a ketchup bottle? Well, if you tilt it at an angle, you can actually get the ketchup to come out very quickly. That's applying Newton's first law. So to summarize, Newton's first law, or often called Galileo's law, or the law of inertia, states that an object at rest will remain at rest. An object at constant velocity will simply remain at constant velocity, unless there is a net force or a unbalanced forces acting upon it. Mathematically, we write sum of the forces is equal to 0, or the net force is equal to 0.